Welcome to the Cisco NETACAD CCNA Introduction to Networks video series by Jason Johnson. This video is Chapter 8, Subnetting IP Networks. The material in this video covers the 6.0 version of the Cisco NETACAD CCNA Introduction to Networks course. I want to thank you for watching my videos. Your time is appreciated. If you find the material helpful, you can subscribe to my channel, and remember to click the notification button if you want to see when I post new content. If you have any questions, you can leave a comment below. And if you watch to the end of the video, I will have links to the next chapter. Okay, so Chapter 8, Subnetting IP Networks. And we're going to talk about why we subnet networks, and we're going to talk about subnetting an IPv4 network, why we do that, and explain how subnetting segments enables better communication. We're also going to look at v4, we're going to look at v6, we're going to look at addressing schemes. We've got a whole bunch to cover here. So 3 sections here that we're going to cover. So let's move forward and let's talk about first the network layer protocols. Now, when we're talking about network segmentation, what do we mean by segmentation? Well, it means we're chopping that network up. We're usually given an IP range or an IP number that has a range of host IP addresses in it when we're given that, and sometimes we need to break that up because we need multiple LANs. So especially in the v4 world, the IPv4 world, where we were given, let's say that we were given a /24 and we had X amount of hosts in there, but now we need to have 2 separate LANs to separate that out on our local area network. So what we would do is we would segment that out, and we still do that. So when we talk about segmentation, though, we have broadcast domains, and that's where each router interface connects to a broadcast domain, and broadcasts are propagated within its broadcast domain. So if we look down here, we've got a router here, and this router has a connection here, and that's a broadcast domain, or you can think of that also as a LAN. And then you have another one over here, you have number 2, and then you have number 3 over here. So the problem with large broadcast domains is that slow network operations, if you have a lot, what will happen if you have a lot of broadcast traffic. So let's just say that you have 100 endpoints, and those will cause a lot of traffic because if you remember back from previous chapters, we have computers, we have the ones that they're sending ARP commands to each other, they're sending IMCP commands to each other, and then just the traffic in general is going to take up all of your bandwidth. So what you want to do is plan your broadcast domains or your local area network so you have smaller segments or smaller broadcast domains so that you don't have all of that traffic on there. So slow device operations are because of a device must accept and process each broadcast packet. And so what we want to do is we want to put domains into smaller areas or smaller groups when we do that. So we do that by subnetting. And when we subnet, the solution with subnetting was to reduce the size of the network to create small broadcast domains or small LANs or local area networks. So because each broadcast domain connects to a different router interface, each domain needs its own network address space. And the process of breaking down an address range into a smaller address space is called subnetting. And you are going to need to know how to subnet. At some point in the future, we will only subnet with IPv6. But for now, you still need to know how to subnet. And I'm going to, and so you just need to know how to do it. So you need to learn how to do it. I've got videos on how to do it. There's lots of other videos out on the internet on how to do it. I've got what I think is an easy way to do it. But there's other ways to do it out there that I've heard some of my students tell me that they found easy as well. So network administrators can group devices into subnets that are determined by location, organizational unit, or OU. You'll see OU from time to time, or a device type. Now, when they break those up, we have to give those segments or different subnets, and you'll hear them called subnets is what you'll hear them called. You won't hear broadcast domain. Usually you're not going to hear broadcast domains or segments. You're going to hear the term subnets. So with the v4 subnet, we have what we call octet boundaries, and if you remember, if we look down here at the bottom, if you've been learning this material, we have 4 octets of 1s and 0s, which make up our IP address and our subnet mask. And so what we do is we subnet on what we call the octet boundary. It's also called a v4 classes. We don't really use classes anymore, the A, B, C, and D, and E. Well, they're still there, but we really pretty much you want to learn classless subnetting. That's what everybody is pretty much doing now. You may get some questions on classes on the A, B, C, D, and E, so you want to study that material. It's in the NETACAD course, or you can find it out on the internet. Just search for classes, IP range classes or IPv4 classes, and you'll find it. What the classless subnet does is it uses address bits to separate networks from host and allows for a lot more flexibility. So an example of that, this would be a /25, and you might see an IP address that's, maybe 192, 192, I'll see if I can draw this out, 192.168, 10.0/25 or /24 or /26. This part right here is the CIDR addressing. That slash is CIDR addressing, CIDR. That's your CIDR address. Your subnet mask is based upon that CIDR addressing. I'm going to go ahead and say right here, I'm not going to show you how to do subnetting in this video. That goes beyond the scope of this video. I've got videos on how to do subnetting, on how to do a quick and easy way to look at a chart, to build a chart, to be able to say you can look at a /25 real quick and say what is the subnet mask. Now with the subnet mask in binary here, see we're looking at the subnet mask here, /25, it's 255.255.255.128. So 255 here is 8 ones, 255 here is 8 ones, 8 ones here, and then the first IP address, or the first bit right here is 128. So we go 1 bit into the 4th octet, and if you remember from a previous video, the way the network reads this is everything after that number of ones is the host. So the host is over here, and the network is over here. So everything to the left of that one, the one and to the left is the network, and everything from this first 0 and over is your host. So on this one, that means we're going to be able to get 2 subnets out of this, and we're going to be able to get 126 hosts per subnet. Again, don't let that confuse you on how we broke that up. Go and watch my other video on how to do subnetting, or subnetting made easy, as I think is what my title was on there, and it will become a lot more clear on how to get that information quickly on there. So, when we create 2 subnets on there, a subnet mask of /25 is applied. So 192.168.10.0 is your first network ID. It creates 2 equal subnets, each one with 126 hosts. So we have 126 hosts here and 126 hosts here. And you may be saying to yourself, why don't we get 128? Well, one is used for the network ID and one is used for the broadcast ID. So we always break it up and then -2, one for the network ID, one for the broadcast ID. Other ways to do that is do 2 to the n power. 2 to the n power -2 is calculates your number of usable hosts. So n is the number of allocated to the network portion of the host. That's one way to do the subnetting. Some people can do it with the math and do it in their head. I use a chart. And if we're going to create 4 subnets, we go one more decimal place. We go one more bit place, and we get a /26. And so now we get 4 equal subnets, each with 62 hosts. Not 64, 62, because one is the network, one is the broadcast. And so that's the -2, which gives us 62. And again, go watch my videos. I've got links in the description below, which will show you how to do that. So you might want to pause this video, go watch that other video, and then come back to this one, because it was, or just watch it afterwards. It will make subnetting a whole lot easier for you. Now, when we create subnets with the /16, it goes the same way. We create 65,534 hosts, and then 18 gives us 16,382, and then 22 gives us create 64 networks with 1,022. See, we went the other way. See, instead of going to the, we get hosts, because we go to the left or to the right, gives us more host or less host, depending upon the network ID. See, and I'm going to go back here. See, so depending on how we move our bit place, if we move it over here, we get more host, and if we move it this way, we get less host, and it's just back and forth. And then depending on where the bit place is going to be how many hosts and how many networks we have. And let me move on forward here. So, subnetting based on host requirements, what you want to do is you have to plan your networks out. You want to put a little bit of consideration into it. And what you don't want to do is say, I need I need 2 subnets, and that's all I'm going to ever need. Well, you may need more than that down the road. So what you have to do is plan a little bit of future planning, and that's where you get with the business that you're working with or working for, and you say, what's your future growth plan to look like? What's it going to be in a year to 2 years down the road? What do you expect it to grow to? Are you going to add 5 new employees 6 months down the road? Do you have a plan for that? And if they do, you want to make sure you plan for that growth. So 2 considerations when planning is that the number of host addresses required for each network and the number of individual subnets needed. So, for example, if we have a router here, let's say we have a router and we have a subnet here and a subnet here, and let's say that we have 5 hosts here and 10 hosts here. And we have, that goes out to the cloud. We just, that's our cloud there that we go out to. And so we know that we need 10 here and 5 here. But let's say the company says we're going to add another 10 here 6 months down the road, so now we're going to need 20 here. And let's say that they're going to add another 10 here, so we're going to need 15 down the road. And let's say, hey, we're going to be adding an accounting department in a year from now when we expand. And we want that to be separated so nobody can see it. Well, that's going to add another subnet on here that you're going to have to plan for. So make sure that you ask those questions ahead of time so that you can be able to subnet that out. Because what you don't want to do is subnet this into 2 and then have to come back in 6 months from now and resubnet it back out and reapply all those IP addresses, because it gets a little bit more messy that way. And if you can do it clean from the beginning, it makes it a whole lot easier. So subnet based on network requirements. Administrators may be asked to subnet an IP range to accommodate a specific number of networks. You want to think of a company with 7 departments where each department must have its own subnetwork, so you need 7 subnets. So the number of hosts per subnet is secondary at that point because you need 7 departments. But if you need 7 departments with 50 hosts each, you're going to need to make sure you plan for that. So a network requirement example would be assume 20.42.98/24 was given to you. 7 subnets must be created, and each department will have no more than 29 hosts each. So you're going to use a subnet mask of /27. That's going to create 8 networks, and that's okay that you have an extra one, but it's going to create 8 subnets with 30 hosts each in each network. Now, what that's going to do for you is you're going to run out of hosts really quickly. So if they said they only need 29, but if they add 5 more people into a subnet, that's going to say, uh-oh, I'm out of hosts now, and so I'm going to have to figure something out. So you're going to have to move and put them in that extra network that you had, that extra subnet that you had, or you're going to have to figure something out at that point. So you just want to keep that into consideration when you plan those hosts out, or those subnets out. Now, the traditional way of subnetting waste addresses, because everything gets split up evenly. So subnets were based on classes. It's not very flexible, results in a lot of wasted addresses. So we went to VLSM, and that's variable length subnet mask, and you're going to hear the term VLSM. You want to memorize that on what that is. So we vary the administrator, or we vary the number of subnets, the number of hosts in each subnet. Basic VLSM, it's down here, and then in practice, I'm going to talk about it a little bit, but again, I've got a video, and it's called VLSM Made Easy, and I walk through how to do VLSM. I think what I think is an easy way to do it. So again, that link will be, I've got a playlist in the description below, and just check that playlist out, and it's going to have the videos on how to subnet in the 4th octet, advanced subnetting, the basics of binary, and also VLSM. So when you do VLSM, for example, and you have, let's say that we have a router here, and we have a router here, and we have a router here, and we have a subnet here and a subnet here, like that. Well, we're gonna need a subnet here, so we're gonna need 1. We're gonna need a subnet here for 2, and we're gonna need a subnet here for 3, and we're gonna need a subnet here for 4. So you're gonna need 4 subnets, but I only need 2 IP addresses. I only need 1 on this line, and I only need 1 on this line over here. And in this subnet, I only need 1 and 2. So you don't want to split that up into 4 and say, hey, I've got all these hosts now that are wasted in here. So what you do is you use VLSM to be able to say, I'm only going to assign 2 IP addresses here for host, and then I'm going to only assign 2 here, and then I'm going to leave the rest of them for down here and down here. And that's how VLSM works. And again, check out my videos. Yes, I'm giving you a plug for my videos, but I created them with the goal in mind of making VLSM a lot easier for you. All right, so let's move to address schemes now. When we plan out network address planning, it requires a decision of each subnet in terms of size, the number of hosts, and how those addresses will be assigned. So your primary planning is you want to prevent duplication of addresses, you want to monitor security and performance, and you want to provide and control access. So, for example, here we have 3 separate subnets here. You have a student LAN, a faculty LAN, and an admin LAN. So they're going to have separate IP addressing so that they can have separate subnets. And that provides some security for you because you don't want students to be able to see the faculty computers. And you don't necessarily have the faculty seeing the admin computers, but you might want to be able to still pass information along back and forth. You might want to be able to email and all, so you would be able to pass those services back and forth without actually seeing files on those actual endpoints. So different devices may also need to impact the addressing scheme. For example, if you have printers, network devices, and gateways, those may need to have separate subnetting and separate addresses on there. So if you have a server or a printer, let's say that we have a router here that those are all connected to, and then we have a print server up here. We have our print server, and that print server is going to be on a separate network so that we can print to that, and they can be able to see that with security that's in place. Okay. So, design considerations for IPv6. V6 is a little bit daunting to some when they first see it. If you're because it's such large numbers and it's hexadecimal, it seems to be intimidating, but it's really not if you just think about it and take it one step at a time and just take it nice and easy. You just have to understand how it's broken down in hexadecimal. So, the V6 global unicast address it normally consists of a /48 global routing prefix, a 16-bit subnet ID, and a 64-bit interface ID. So a 16-bit subnet ID and a 64-bit on there. So the subnetting using the subnet ID. The subnet ID provides plenty of subnets and host support in one subnet, and I think it's way above Google. It's just a huge number. You can go look it up. So if you go and look up this is the number of hosts, or this is the number of subnets it allows, a /64. And a /64 is breaking that hexadecimal IPv6 in 2. So it's only halving it, and half of that 64 gives you 65,536 subnets, not host, subnets. And each one of those subnets gives you, I forget what it is. It's a number well above trillion. I mean quadrillion or something like that. It's a huge number. You can go look it up. You can go look up the number of IP addresses per 64 subnet, but it's just off the charts large number. So the subnet allocation is address waste is not a concern in v6 at this point, and v4 wasn't at the point they created it, but it quickly become. So, but with such large addressing space, I don't really think in my lifetime, I'm 50 years old, I don't think in my lifetime, in the next 50 years, even if I live to be 100, I don't think we'll even get close to running out of IPv6 addresses. It's such a large number that I just don't think we ever will. So administrators can concentrate on designing a logical scheme to address the network. And so here, see, we're using the first range there, 0001, 0002, 4, 5, and each one of those is just going to have all kinds of host addresses that you can do. So everything can have an IP address. And that's where we come up with the term of Internet of Everything, because everything can be on the internet at some point. So don't let it intimidate you. Just take it, just research on the hexadecimal and research the v6 and then understand that. All right, so we are bringing Chapter 8 to a close. We have looked at v4 addressing schemes. We looked at the set of requirements and how we would break down. Go check out my videos on IP or subnetting. Go check it out on VLSM. It'll make it a lot easier for you. Don't let v6 become too daunting for you. Don't let it overwhelm you. We briefly looked at v6 and how it breaks down, and you're going to learn more about v6 in your material in the NETACAD course. So I hope this video was helpful for you. If it was, go down and give me a thumbs up down below or leave me a comment. I love to hear comments from those that watch my videos, and I hope you have a great day.